Hello everyone and welcome to this tutorial. In this series of tutorials, we are going to be looking at Linkforge. Linkforge is an amazing add-on for Blender that was created to enable robotic enthusiasts, robotic professionals to easily export their CAD models from Blender into URDF or Sacro. So here I have the documentation for Linkforge and also the page on Blender extension page. So the developer is Haruna Patoza. A big shout out to him. It's really great job done with Linkforge. So to download Linkforge, it's very simple. Before now, I created some tutorials on how to set up Phobos for Blender. Phobos and Linkforge are basically used for the same thing. They are just tools that enable us to export our CAD models into URDF. It's a little bit complicated to set up Phobos. You can check my tutorial on how to set up Phobos on my channel. But to set up Linkforge, it's very simple compared to setting up Phobos. So to set up Linkforge, you can simply come to Blender and you can click on Edit, Preference. So to install Linkforge, since it's available on the Blender extension page, you can just search for Linkforge, and you are going to have it displayed in the Blender extensions. You can either use add-ons or get extensions. It's still going to link to the same page. Here you can see I have Linkforge installed already. If you are just setting up your Linkforge, you might have an install button just close to Linkforge. For me, I have it installed already, so I'll just go ahead and start using it. So that's basically how to install Linkforge. Very simple and straightforward, and yeah, you should be good to go. So once you are done installing Linkforge and you press the N key to show the context menu, you're going to have Linkforge as part of the list. Here you can see I already have Phobos installed. Again, if you want to learn more about how Phobos work, or you prefer to use Phobos in your development, you can check out the tutorial on my channel. To get started with Linkforge, a lot of work has been done already on the documentation page. You can just go to linkforge.readydocs.io, where you're going to find a lot of information about Linkforge. And I'm going to be following a tutorial I found on the site on how to create a simple differential drive robot. And basically, yeah, just following along what we have on this page, doing everything step by step. I'm sure you can follow along by watching the video or by simply following along what is available on this tutorial page. So I already have this simple CAD model in Blender. This can be your robot, this can be anything at all. I just have this model plainly the way you model anything in Blender. And then we're going to be setting this up for URDF exporting using Linkforge. So let me start by, basically what we're going to do is going to be divided into three. The first one is to create link, second one will be to create joint, and third one will be to create collision. Once you have done those three, then we can export URDF. So the first thing I want to do is to create link. What I have to do is to tell my URDF that all these things, they are all visual elements and they should be exported as part of my URDF. So I'll select them one after the other. I'll select all my elements. So the first one that I have is this. And again, once you bring up the Linkforge context menu, I can click on Linkforge. It says different options here: import or export URDF, create link, add empty link, and some other things are grayed out for now. So what you have to select based on the documentation is create link from mesh. You want to create a link from this particular mesh. So I'll click on create link from mesh. And here I'll have the opportunity to give a name to my link. I'm just going to call this base link. Now it's stated on the documentation page that the collision should be left at auto so that it will automatically generate the collision parameters. It should always be left at autos. Once that is done, we can again set a mass. You can set this based on what your physical robot look like. I'll just put a value here like 5.0. The auto calculate inertia should always be left check. You can maybe uncheck this if you have some different parameters, but the way the Linkforge has been built, a lot of calculations have been built into the add-on so that it automatically can calculate all these other parameters for you. So once you have set your mass, you've set your name, you can click on generate collision. So it's going to generate collision for your object. This is what you're going to be doing for all the other meshes like that. So let's do the same thing for the two wheels and the LiDAR sensor. So I'm going to click on this. So once we are done creating the links, the next thing we have to do is to create joints. So I'm going to be creating joints that joins the left wheel, right wheel, and the LiDAR to the base link. So I simply have to select the wheel and then click on create joint. So it's going to create a form of joint for me, and then I can select the type of joint it is here. For the wheel, it's going to be a continuous joint. This can be any joint at all based on what you are working on, continuous joint, and then the parent link is the base link. Now, you can select the axis of rotation, X, Y, or Z, based on your design. If it's not correct, after simulating this, you can always come back to Linkforge to recreate the joint. So I've done it for the left wheel. I also do the same thing for the right wheel. So for the LiDAR link, it's going to be a fixed joint. So I'm going to select fixed joint here and select the parent link also as a base link. So now we are done creating the joints for our robot. Sometimes we have sensors attached to our robot. Like in this case, we have a LiDAR sensor attached to our robot. So we can also configure this in Linkforge. You can choose to do this in Linkforge or export this as URDF and do it over there. I explained something like this when I was talking about Phobos. But for Linkforge, you can create your sensor from the CAD. So I'm going to select my LiDAR, and then under passive, I'm going to create a sensor. So create sensor. It's going to ask which type of sensor it is. You can always give this a name, maybe a LiDAR sensor or any sensor at all that you are creating for. So I'm going to select the sensor type, camera. So it's a LiDAR in this case, LiDAR, and then you can select the update rate, every other parameter that you can set up while working with a LiDAR sensor normally in URDF. After creating all this, you can choose to export your URDF. This is well enough for working while simulating in Gazebo or RFix. One way you can do this is to click on validate and export and try to validate our robot. If I click on validate robot, it shows that the robot is valid, 4 links, 3 joints, and 2 degrees of freedom. But sometimes you want to also create the ROS2 control. Again, you can choose to do this here in Blender or just export your URDF first and then update this on the URDF. One thing I would recommend is that for now, you can always do this, set up this in Linkforge, but sometimes the ROS2 control plugins might change, the Gazebo plugins might change, and you might need to edit this manually after exporting the URDF. But to set up ROS2 control, what I have to click on is control, and then you have the option to click on use ROS2 control. So we want to use ROS2 control to control our wheels, both the left wheel and the right wheel. So we have to add the joint interfaces. Here it says joint interfaces plus we can add. So what we want to control is the left wheel joint again and the right wheel joint. Now for the command inertias, we are going to have velocity checked, not position. And for the state interfaces, we are going to have both position and velocity checked. After doing this for the right wheel, we do the same thing for the left wheel. Click on left wheel, check position, check velocity on check position, and for the state interfaces, leave position and velocity checked. So with this, we have our ROS2 control set up for the 2 wheels. We can again validate our robots by clicking on validate robot. Once everything is correct, we can then export the URDF. You can just come down here, and you don't need to set this up since we are not using meshes. If you are using meshes, you can just maybe put STL or object. So meshes and primitives are 2 different things. If you are using just squares, cylinders, cubes, you can just export everything without using meshes. But if you have some composite shapes that cannot be defined by a particular shape, you can always go with meshes. Once everything is done, just click on export URDF/sacro, and it will prompt you where you want to save it. So I currently want to dump it in the same directory as my Blender file. So I'll just export URDF. Now it shows that it has been exported. If I go to my file, I have it 02.urdf. I can double click on this and I have it displayed. If I want to quickly visualize this in RFX to make sure everything is the way it's supposed to be, I can actually maybe create a package for it. You can check my tutorial on Phobos to see how you can create a package for a custom URDF. But to quickly view this using URDF tutorial, which is an inbuilt tutorial in Rust that I can use to visualize URDF, I just have to quickly come down to this line and where I have find package and change this to URDF tutorial. So once I change this to URDF tutorial, I can go into my terminal and launch the ROS2 launch URDF tutorial display.launch.py and select the model, which is 02.urdf. Can open this up, and it's going to open two things up for me: the joint state publisher and also the artfix. So here I have my robot display in artvis. I can look at the wheel movements if I try to. Now, one thing you notice that my wheel is not well positioned. While moving the left wheel, it's moving in the wrong direction again for the left wheel also. So you can always come back to Blender and set this up. Just what you have to notice that if you try to select the whole cube or the link, it does not show the joint. It will ask you to maybe to create another joint. If you want to actually work with a joint, you want to modify a joint, just select one of the coordinates and then the joint will be selected. Now I can change my joints to x-axis, y-axis, and it's going to reflect after exporting the URDF. So yeah, that's basically all how you can work with Linkforge in Blender. I hope you find this tutorial useful. I hope you find it interesting. It's very easy to set up Linkforge. Once you have a model design in Blender, you can still install Linkforge and export it as URDF and simulate it using any simulator of your choice, Arvis, Gazebo, Isaac Sim, or anything at all. So thanks so much. If you find this tutorial useful, don't forget to give me a thumbs up, a like, and also subscribe to the channel. And if there's any question, you can always drop the question in the comment section and I will do well to reply as fast as possible. So thanks so much, and I'll see you in the next tutorial.